is required for solving the numericals, and numericals are very, very important for the exam point of view. So for that, and this is the sign convention for all types of lenses. Okay, means for the convex and the concave lens, the sign convention will be followed. And we have already also discussed when we were discussing the mirrors. In case of mirrors, there are also sign conventions, I have told you. So here also, in case of lenses, today we will see how the sign conventions are there. So I am taking first the convex lens, and accordingly I will tell you the sign convention. Sign convention, the word convention, the word says that means you can take the sign according to you also. If there is a sign convention, means this is not required that the sign convention I am telling, okay, you should follow for solving the numerical only. Okay, only that sign convention that, that I am telling. Okay, so but uh, the sign convention that we will discuss here uh, will make the solution of the numerical easy. Okay, so you will follow the sign convention that I am going to tell you, but it is not recommend. It is not mandatory that the left hand side of the lens is positive or the right hand side of the lens is taken as negative. This can be changed, but here we have to follow the sign convention that I am telling. So I am taking the convex lens. Okay, I am taking the convex lens, and the principal axis is this. Suppose this is the principal axis, and what is this point, Azaan? What is this point?
Optical center.
Yeah, optical center. Good. And this line is the principal axis. So all the distances will be measured with respect to this point and with respect to this line. So if the light is, suppose the object is here, I have placed an object, this is an object. The object is here. And if object is here, so how the light will come towards the lens? The light will come like this. This will be the direction of
Yes, sir.
incident light. Direction of incident light, because the object is a source of light, na? So the light will come in this direction. So the with respect to the direction of the light, in which direction the light is coming or in which direction the light is going, we will describe the sign convention. So and always remember that you will always measure the distance from the optical center, and if you want to measure the height, you will measure with respect to principal axis. So suppose your object is here, in this direction. So what will be the distance of this object from this? Is this, no? This is the distance between the object and the optical center. Just wait, you will get each and everything.
Okay, sir.
Yeah. So for measuring the distance, we are moving means Azaan, first write these things. Okay, then we will discuss this. Then you will this thing will be clear, much more clear.
Okay, sir.
So just write all the point. I am just explaining it one by one. Uh, all the distances are measured from the optical center of the lens. This thing is clear. Second thing they are saying the distances measured in the same direction as that of incident light are taken as positive. Okay. And other point is the distance measured against the direction of the incident light are taken as negative. And again, they are saying the distance measured upward and the perpendicular to the principal axis are taken as positive. The distance measured downward and the perpendicular to the principal axis is taken as negative. Please write all this point. After that, I will tell you. Then things will become more clear. And this is your heading: sign convention for spherical lenses. Azan, which chapter is going on in your school?
Sir, we started human eye and colorful world.
Okay, so we are also just going to start the chapter because we are at the last of this chapter.
Okay, sir.
We will also start the human eye and the colorful world. When completed, you can tell.
Yes, sir. Done.
Done? This part done? Okay. So now see. Now this is your object, na? This is your object, and suppose you are here at the optical center. You are at optical center, and for measuring the not I am not talking about the measuring and all that. For reaching the object, in which direction you have to move? In this direction, na? You will move in this direction, like this, like this, like this. So in which direction you are moving? In the opposite direction of the incident light or in the same direction of incident light? Means you are moving in this direction. So it means that you are moving in the opposite direction of incident light.
Yes,
So
sir.
if you are moving in the opposite direction of light for measuring the distance, then you will consider that distance as a negative distance. And this is the point number this here this is written here in point number third. It is written the distances measured against the direction of incident light are taken as negative. So I am not writing here. I am just writing u here. U is the object distance, and u here you will take negative. And what is u? U is the object distance. And suppose your image is here. This is your image. Suppose. So for measuring the distance of image or for reaching the image, and you are here, here, and you have to go to the image. So you will move in this direction. You will move in this direction, and this direction is same as that of incident light or opposite. Azaan,
Yes, sir.
this direction this direction is the opposite direction or same direction of the incident light, na? This direction,
Yes, sir.
and this, and here point number 4, the distance measured the distance measured in the same direction as that of incident light is taken as positive. So if you will measure the distance in this direction, means in the direction of incident light, so you will take this distance as positive, and the distance between the optical center and the image, I have already told you, is the image distance, and this is represented by v, and here you will take image distance as positive in this case. This is
Okay,
image
sir.
distance. Image distance. Suppose Azaan, your image is here. This is your image this time. So will you take positive image distance or negative image distance if your image is here?
Sir, negative.
Very good. You can easily solve the numericals if you know these things. Now, for the height of the object, if your object is above this principal axis, if your object is above this principal axis, then you will take the height of the object as positive. So you can see this point. The distance is measured upward and perpendicular to the principal axis is taken as positive. So we are measuring this distance in the upward direction. Okay. And this is also perpendicular to the principal axis. So this distance is known as height of object, and this height of object you will take positive. Okay. And here also, for the case of image, the height of the image you will take positive. Suppose if your image is like this, see here now, your image is like this, then in this case, height of image you will take negative if this is your image. If this is your image, then height of image you will take positive. Okay. So if your image is like this means you are moving in upward direction to measure the height of the image and perpendicular to the principal axis also. Then you will take it positive, or otherwise you will take it negative. So HI means height of image HO means height of object. Just note it down. The direction, the sign convention should be clear, and you will consider the sign convention with respect to the direction of the light when you are measuring the object distance or the image distance. And when you will measure the height of the object or height of the image, then you will see with respect to the principal axis. If with respect to the principal axis you are moving in the upward direction and also perpendicular to the principal axis, then you will take height of object or image as uh, positive. If you are moving in the downward direction, then you will take it as negative. Just copy this. Then we will discuss what is lens formula. This is your object. And this is your convex lens. When completed, please tell me.
Done, sir.
Done. Very good. So just note one point here. Focal length of convex lens. You will always take focal length of convex lens as positive. Is positive. Okay. Focal length means small f, and focal length of concave lens is negative. Just add this point. When we will solve the numerical, you will get how we will take the image distance as positive or image distance
Yes,
as
sir.
negative. So next thing is, now Azaan, do you have any doubt regarding this sign conventions? Because this sign convention is one of the most important part for the numerical solving.
No, sir.
Just I am moving. So we have now lens formula. Earlier we have a mirror formula, na? This is the mirror formula we have earlier. You can see here. Mirror formula, what was? Means mirror formula is 1 upon f is equal to 1 upon v plus 1 upon u. Okay. So now just write this lens formula. So I am removing this mirror formula because we have already discussed what is mirror formula. So just remember the difference. Here is plus and here is minus. In length formula is minus and here is plus. So I am removing the formula. So just write this length formula. Length formula is 1 upon V minus 1 upon U is equal to 1 upon F. And what is V? V is image distance. And I have already told you we will always measure the distance of object, distance of image with respect to optical center. And U is the object distance and F is the focal length. So this formula we will use in the numerical. Just copy this. Then we will discuss what is the linear magnification of this of the lens. Azaan completed?
Yes, sir.
Okay. So this is the lens formula. Remember, this is 1 upon V minus 1 upon U is equal to 1 upon F. And magnification, just write the heading magnification produced by lenses. So the linear magnification, okay, we are talking about only linear magnification. So magnification is we have two formulas for the magnification: height of the image and the height of the object. Okay, so magnification I will represent it with M. Okay, and this magnification is equal to height of image divided by height of object, and this is also image distance divided by the object distance. So just note all the points. Image distance is here, it will write V divided by U. In numerical, we will use both these formulas. Just copy this. The heading is the magnification produced by lenses. And we are only talking about the linear magnification. And HI, what is HI, Azaan? Height of
Height
image.
of image.
And HO is the height of object. Just copy this, then we will solve the numerical. With the help of magnification, we can compare the size of the image with object. So completed, Azaan?
Yes.
So now the numericals we will solve. For the numericals, there are requirements of first sign convention we should know, and another we should know the lens formula, and we should know the magnification. So what is the lens formula? 1 upon V minus 1 upon U is equal to 1 upon F. What is magnification? Height of image divided by height of object. This is also equal to V by U. So these two formulas mainly used in the numericals. Okay. So see this numerical. They are saying a convex lens of focal length 10 centimeter is placed at a distance of 12 centimeter from a wall. How far from the lens should an object be placed so that to form its real image on the wall? So a convex lens is there. A convex lens is there. And here is one wall. Okay. Here is one wall. This is wall. This is lens. And this point is the optical center of the lens. And this line is the principal axis. And they are saying that a convex lens of focal length 10 centimeter. I have told you, you will take focal length of convex lens as positive. So you will take to plus 20 centimeter. Okay. And this is placed at a distance of 12 centimeter from the wall. So this lens is at a distance of 12 centimeter from the wall, means this distance is 12. Okay. This distance is 12 centimeter. They are saying how far from this lens should an object be placed to form a real image on the wall. So they are saying where you will place your object so that you will get your image on this wall. You will get the real image on the wall. Okay. So the meaning of this statement is that we don't know where we have to put the object. Okay. So what we will do? Suppose I am placing the object here. This is the object O. AB is the object. I have placed the object here. And I am taking the object distance this is the object distance I am taking. So I am measuring, this is the object now. From this object, the light will come in this direction. Light will come in this direction. And you are going in this direction to measure the object distance. So object distance is U. So, okay. U is the object distance. So means your object is at a distance of U from the lens, and you will not decide the sign of unknown quantity. Here U is unknown. Okay. But they are saying the image is forming on the wall. So the image distance is this distance. And image distance, for measuring the image distance, you are moving in this direction, means you are moving in the direction of the light. Then you will take this image distance positive, and this is given as this. What is this distance? Azaan, can you tell me the image distance?
10 centimeter.
12 centimeter. You will take plus 12 centimeter. Okay. Why you are taking the plus 12 centimeter? Because the direction of the incident light will be like this, because object will give the light in this direction. Incident light. And our image is forming on the wall. So the image distance is 12 centimeter. This is already given. So what we will do? We will just apply the lens formula. 1 upon v minus 1 upon u is equal to 1 upon f. And we will not take any sign for u because we do not know what is the value of u, or u is an unknown quantity. So for unknown quantity you will not take any sign. So what is 1 upon v? 1 upon v is 1 upon 12. This is plus 12. This is minus 1 upon u, we do not know. And what is focal length? Plus 20 centimeter you will put here. So Azaan, can you solve this?
Sir, why will you put 20 centimeter? Because it is given 10 centimeter in the question.
Oh, okay. Sorry. We can change it. If it is given 10 centimeter, then we will put 10 centimeter. Okay. So just put 10 centimeter. Thanks, Azaan. Okay. Azaan, can you solve it? For
Yes, sir.
just please solve it and tell me the answer. Just solve it. Take the LCM. I have told you na in maths when we were discussing the chapter number 1, real numbers. So I have told you how to take the LCM of two numbers.
Sir, I got minus 1 by 30.
Minus 1 by 30. Okay.
Yes, sir.
Fine, no problem. When you will take the LCM of this 12 and 10, so you will get 60. Because 12 is in the table of, sorry, 60 is in the table of 12. 12 5s are 60. And 60 is also in the table of 10. So when you will solve, you will get 12 5s are. Here you will write 5 and here you will write 6. Okay. And here 5 minus 6 you will get minus 1 divided by 60.
Sir,
So
why
finally
5 minus 6?
5 minus 6 is because the LCM is 60 na, of 12 and 10.
Sir, we will cross multiply, right?
Okay, from that method also we will check the answer, no problem.
Okay.
So you are getting minus 60 centimeter. What is the meaning of this minus sign? This negative sign.
Sir, it is
So
behind the limit.
you can say the behind, but the right word is that your object, you can say, means you are measuring this minus sign according to the sign convention is that you are going in the opposite direction of the light for measuring the distance. So this object will not be here, because if the object will be here, the object distance will become positive. This object distance will be negative only possible when you will place the object on this side of lens. Okay, so this you will get, initially I do not know whether the object is on the left side of the lens or on the right side of the lens. I have just assumed that the object is here. Okay, but finally from this sign it is confirmed that the object is on the left side. Okay, so u is 60 centimeter, or you can say minus 60 centi. What is the meaning of this? This distance is 60 centimeter. So your answer is now clear. Now
Sir,
you
can
are
you
saying
show
that,
from cross multiplying?
yeah, of course.
Okay, sir.
Okay, now from the cross multiplication method, what you will do here, you will just multiply this 12 into 10. So 12 into 10. Then what you will do? You will multiply this 10 with 1. So what is 10 with 1 is 10.
Yes,
You will multiply this 12 with 1.
yes.
Okay. So this is 10, this is
Okay,
12.
sir, I got it.
Got it now? This will become 120.
Yes, sir.
Here you will get minus 2. Here is 120. And when you will divide 2 with 120 with 2, you will get this. And again you will get your answer as minus 60 centimeter.
So, sir, in cross multiply method, we should not take LCM.
In cross multiplication, actually one thing, there are two things here. When we should use the cross multiplication method, when we should use the LCM method. Cross multiplication method, there is no requirement of LCM. But suppose if I am giving you a number, very larger number, then in that case your calculation will become lengthy. So that is why I always use this LCM method. Okay, so you are right that in cross multiplication method, there is no requirement of LCM. Okay, you
Okay,
will
sir.
just simply multiply. And one thing you can notice here, one thing, what you have done, I have taken here 60 na, and you have taken here 120. So now you can see there, this 120 will be in, definitely this 120 will be in the table of 12. 12 tens are 120, and this
Yes, sir.
120 will also in the table of 10 when you will go 10 into 12, mean 10 11s are 10 12s are 120. So this is just the simple mathematics. You can solve it by the cross multiplication method or by the LCM method. I prefer LCM method because the calculation become easy. So that is why I use this. So the answer will remain same. So you can just note this question and answer. And I am telling it again and again. Initially, I do not know the object is on the left side of the mirror, or left side of the lens. Okay. Just copy this. So why focal length is
Done, sir.
plus 10 centimeter? Because it is a convex lens. Done? Completely done?
Yes, sir.
So got it how to solve the numerical?
Yes, sir.
So sign convention you can see is very important. So another question. So see this question. They are saying that if an object of 7 centimeter height, means this time the height of the object height, suppose this is the object in this question and the height of this object is given. So they are saying if the object of 7 centimeter height is placed at a distance of 12 centimeter from the lens of focal length, from a convex lens of focal length 8 centimeter, find the position, nature and the height of the image. This question is very easy question. So first what you will do, first try to always make the figure or the diagram of the question, because from the diagram each and everything will be clear. So this is the focal, this is the convex lens, and this is the optical center, and your object is, they are saying object is of height 7 centimeter placed at a distance of 12 centimeter from the convex length of focal length. So Azaan, can I this is the left side, this is the right side. So which side is it possible to place the object on the right side of
No,
this
sir.
lens? Why?
Sir, because it is a convex lens.
Azaan, we can put the object on the right side. Suppose I have just reversed this screen. So what you will do? Suppose I have reversed the lens. So means both the sides of the lens we can put the object. Okay. This is not mandatory. Suppose you are having a lens. Suppose you are having this lens. You can put the object here also. You can put the object here also. This is not the mirror. This is a lens. Okay. So generally we take in the question, generally always we prefer the left side. Okay. But I can also place the object at the right side. Okay. If I will place the object here, if I will place the object here, so what will happen? The direction of the light will be in this direction, and accordingly the sign convention will change. But what we will do, we will just place the object always in the left side. Okay, Azaan, so got it?
Yes.
If someone is asking that, can you only place the object on the left side? No, we can also place the object on the right side. So direction of the incident light will be this, and your object is placed here. This is the U, and this is object. And focal length is given as and height of the object is given. So this height is given as 7 centimeter. So height of object is 7 centimeter. So you will take the height of object as positive or negative, because your object is above the principal axis. So height of the object you will take positive.
Positive.
And focal length you will take positive or negative. Again you will take focal length as positive, because this is a
Positive.
convex lens. Focal length is not given, na? Given 8 centimeters is given. Focal length 8 centimeters is given, and they are saying this height is 7 centimeter and object is placed at a distance of 12 centimeter. So this U is 12. So means I you will take this 12 centimeter as positive or negative. Means you, this 12 centimeter you will take positive or negative.
Negative, sir.
Negative, because for measuring the object distance you are moving in the opposite direction of the light. Okay, this is negative 12 centimeter. This is the incident light. And incident light will be decided by the position of the object. If your object will on this side, then your incident light will be from here to here, because object is a source of light. So all the things we have, now we will apply this formula, lens formula. 1 upon V, 1 upon U, 1 upon F. Now you can calculate the 1 upon what is 1 upon U? You will take this as minus 12. And what is 1 upon F? This is 1. Can you calculate this time?
Yes.
Just calculate it and tell me the answer.
Sir, the minus 1 by minus 12 will become 1 by 12, right?
Yeah, you are right. Because this is minus, and actually, listen, this thing now you can write like this also. This is minus 1 by 12. Okay. This
Yes, sir.
1 by 12, no? This minus sign can be in the numerator or can be in the denominator. There is no problem. So what will happen? This minus and minus, when you will multiply, it will become plus. So finally it will become plus 1 by 12. Okay. And finally you will get 1 by 8 minus 1 by 12. Just solve it by the LCM method if you want, or by your multiplication method.
I will do it.
No problem. This is not 36. 48. So it will become minus 2. So you are placing the object at this answer is this is 2 na? And this is 48. So your V will become plus 24 centimeter. So you now see here. Now you this positive sign. What this positive sign signify? Means you are measuring the image distance in the direction of the light. So means you will measure the distance from this here, from this optical center. So from this optical center to go to the image, you will move in this direction. Means the image is at the right side. The image is at
Yes,
the
sir.
right side. So
Yes, sir.
here is somewhere image. So image distance is this.
Done, sir.
Image is at right side. This sign shows that. And after that, you have to find the nature and height of the image. So if the image is
Sir, we
so
will use the height of image by height of object
yeah,
formula.
nature and all that you will get from the magnification. So this is height of image by height of object is equal to V by U. So height of image you do not have, height of object you have 7, and V you have plus 24, and what is U? U you have minus 12. So this is minus 2. So height of image will be minus 14 centimeter. So now this minus sign in the image of height of image signify that the image will be below the principal axis. Okay?
क्या?
आपके प्रिंसिपल कैसे लिखता है?
Image will be below the
Principal?
principal axis.
कैसे लिखते हैं?
पतली
पतले
पतली है.
अच्छा पतले है पतले.
So your this image will be like this. Okay, your image will be like this, and this image is at a distance of 24 centimeter. So one thing, please note one thing here. If your magnification is positive, if your magnification is positive, then your image is virtual and erect. Note, if your magnification is positive, then your image will be virtual and erect. And if
Sir,
your
in this
magnification,
question, image
yeah,
is real and inverted.
yeah, real and inverted. So means got it, na? This when you will calculate the magnification for the nature of the image, so you will use V by U, because you cannot use this formula for calculating the magnification because you do not have height of the image. You have this, so you will get this negative because this is plus 24 and this is minus 12. So you will get minus 2, and you are getting your magnification negative. So it means that your image will be real and inverted. Okay, and what
Yes,
is the size of the image? Size of the image will be 14 centimeter. So the height of your image or size of the image will be 14 centimeter, and your image will be below the principal axis like this because of this negative sign. Okay, so for the nature you can
okay.
write, for the nature you can write, you are getting magnification as negative, that is minus 2. So you can say that your image will be real and inverted. So from the diagram each and everything is clear. You can see here the image is inverted now like this, and according to the negative sign you can get or from the magnification you can also get. So just note this down.
Sir, the position of the image will be 24 centimeter in front of the lens, right? On the
No,
right
no,
side.
no, 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 no. Not in the front, because see here, this is a positive sign, na? This is the positive sign. This is the positive sign. If this is a positive sign, means you are going in this direction to measure the image distance. Then only this distance will be positive, na? So your image
Yes,
will be,
sir.
you can say, behind the lens if your object is here. Okay. With respect to the object,
Okay, sir.
or you can simply say your image will be on the hello Jan, are you there?
Yes, sir. Yes.
So actually there is a power cut. So got it now? Why this I have taken the
Yes, sir.
image on the right side. So just
Yes, sir.
copy this. Just copy this.
Sir, done, sir. Sir, can you show the
Already.
first problem question?
Okay, this is your question.
No, sir, the previous question.
Okay, the
I
previous
wasn't
question.
able to write the question.
Okay. So this is your previous question. Okay, just let me make it shorter. Okay, this is your previous question.
Okay, sir.
Okay, completed now all of the things,
Yes, sir. Yes,
and
sir.
have got the sign convention. How you will take the sign convention? How you will apply the formula?
Yes, sir.
And if you want to find that your image is virtual and erect, you should see the sign of the magnification that you are getting.
Okay, sir.
So in this way, if you will solve the question, then 100% you will get your answer correctly.